I am Anil Kumar. Welcome to my series on vectors. Let me thank my student Gurmeen for sharing this question with me. Gurmeen, I am sure you have solved this question using the method of writing lines as a linear combination. That is definitely the method which you have learned so far. Now, the same example, I'll provide you with an alternate solution. You'll also notice that I've modified this question a bit. The question now is, show that the following equations represent the same plane, so that part is same. And second part of this question is, find scalar equation of the plane they represent. We also call this as Cartesian equation. Okay, so that's your next chapter also. So solution which I'm going to provide you now will help you to understand the next chapter. Now here we are given two planes, r equals to u minus 324 and v minus 471, where u and v belong to real numbers. The other one is s times these vectors. Now these two, as you can understand, are the two directions. So they represent directions of two different lines on a plane. To show that is the same plane, we could definitely use the method which you have applied, writing linear combinations, right? This with the other two, that with these two, right? Now, as I was saying, in Cartesian equation, which is the next part of the chapter, we actually consider the normal. A plane can be actually defined by the normal vector. So if this is a plane, right, so in that case, if I know that this vector is normal, right, to this particular plane, and from a particular point, which normally is the origin, if I have the distance d, then the plane is uniquely defined. So normal and the distance define the plane. So at present what you have is, on the given plane you have two directions which represent two different lines, right? So one kind of like this, let us say, right? And let's say the other one could be something like this. Now if I take cross product of these two lines, in that case what happens? If I take the cross product of these two lines, we get the normal, right? So what we will do here is we'll find normal for the first one. Let's call this as n1. And similarly, we'll also find normal for the second one. You'll also notice that the equation shows that origin, which is 0, 0, 0, lies on both the planes, right? So if I show that normals are scalar multiples, in that case we know we have a common point. So this is a common point, right? Since we know this is a common point, from the normal itself we can ensure that the two planes are same. So let's find the normal. So normal means the cross product, right? So let's find the normal for the first one, which is the cross product of these two, right? So we are basically trying to find what is minus 324 cross minus 471, right? Which I'll use the matrix method. So we have I, j, k. These are the unit vectors. And you have minus 324 minus 471. Now that gives you I times 2, 7 minus 4 is 7 times 4 is 28, minus j, that gives you minus 3, and that gives you, that is minus and minus becomes plus 16, and then with k we get minus 21, and that becomes plus 8. Now this is with k, right? You can use the method which you have learned to do the cross multiplication. You'll get the same result. So what we get here is minus 26i, and that is minus 13j. I, j, k are the unit vectors, And here what we get, 21 is minus and 8 is plus. So we get 13 minus 13k, right? So that is the normal for the first plane given to us, right? Now let us find the normal for the second one. For the second one, we'll do cross multiplication of these. So cross product is minus 1, 5, minus 3. Cross product with minus 1, minus 5, 7. So using the same method, so we get I, j, k, minus 1, 5, minus 3, minus 1, minus 5, 7, right? So we get here equals to I, 5 times 7, 35. So we cross multiply and take away that. So 35 minus 15 minus j. So that goes in alternate, plus minus plus coefficients, right? And this is minus 1 times 7 as minus 7, minus of this, which is minus 3. Then we have plus k. So minus 1 times minus 5, which is 5. And this is negative, makes it positive 5. So that gives you, so 13 take away 15 gives you 20. Okay, so we could write 20i, that's better. And here we get minus and minus becomes plus 10j. And this is also plus 10k, right? That's what we get. Well, now what you see is we can actually write on in simpler form. So this, if I take away minus 13 common here, what do I get? If I take away minus 13 common, I get 2i minus j minus k, correct? And in this case, if I take 10 common, so I took minus 13 common, so all of them become positive, sorry. Right? So in this case, all are positive. I'm taking 10 common. I get I, 2i, plus j, plus k. As you can see, these are scalar multiples, right? Scalar multiples of 2i plus j plus k, right? So they are scalar multiples of 2i plus j minus k, correct? So that shows that both of them are actually the same plane because their normal equation is exactly same, correct? So that is how you actually get the equation itself. Now in this particular case, since we know that point 0, 0, 0 is on this particular plane, we can do the part B, which is writing the equation of the plane. Let's say pi. The plane can now be written as, these are your scalar multiples, these are your normals, right? So normal with the plane going through origin will be 2 times x, and this is 1 times y plus j equals to 0, right? Because the normal, we are taking this as the simplified form, 2i plus j plus k. Does it make sense to you? So that is how we can actually get the equation in the Cartesian form. And this equation is common for both. They are the same planes. So I hope that makes sense. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that would be great. Thanks for watching and all the best.